Hi, I'm Elisa Wood. I'm the editor of Microgrid Knowledge, and I'm here today with Mike Carlson from Siemens. And we're going to talk about microgrid intelligence. So Mike, one of the key features of a microgrid, what sets it apart from other forms of generation, is that it has an intelligent component, a brain. Can you describe that a bit to us?
So if you look at today's microgrids, they've been established for pretty much a discrete purpose. Started with resiliency and reliability for a hospital or an educational campus or military was probably one of the main examples. And those installations have an intelligence embedded within the machines that operate those machines for that discrete purpose. As you see microgrids and tapping the value of the potential of the microgrid equipment beyond that initial objective, you start to see the need for an added extension of intelligence. And that intelligence is generated by the sensors embedded in the equipment, the communication of that data off those sensors, but then the visualization, the situational awareness, and then actually the analytics of other things that can be done to utilize and optimize that asset value. So as we look at microgrids expanding, the optimization of that investment, so to speak, beyond its initial purpose, but extending to a broader grid purpose, is an area that we see software becoming a bigger player. And as Bill Gates recognized early on, it wasn't just the hardware, but in fact, true value was extracted out of the software. So at Siemens, that's a major focus for us from the intelligence of the individual equipment, but bringing it together into a collaborative integration of data across the equipment spectrum and arguably across the entire grid.
Interesting. So give us some examples. I know you have a project, very interesting project in Northern California. It's Blue Lake Rancheria. Can you tell us a little bit about that and how intelligence works within that project?
So the Blue Lake project in Northern California was interesting from many perspectives. Indian reservation at the end of a PG&E line, quite some distance from most any other infrastructure. And so not only the sustainability, but the expansion of that community was dependent on a single line. As their demand started to grow, they looked at options, including how PG&E could service them as a standard utility grid. And it was determined from an economic, an option, and a sustainability perspective that perhaps there was a different model. So the uniqueness of Blue Lake not only is in what they put together, but the fact that it was a partnership between Blue Lake, PG&E, and Siemens to put optionality from an economic, a sustainability, and a reliability perspective into that community. So it married cogeneration, solar, they've got a green component, they've got storage, they can obviously add other components of generating capacity into the model, but because it works in concert with PG&E's system, it needed to be more than just its own standalone intelligence, but an integrated intelligence. So our microgrid controller and our device monitors operate for first the community of Blue Lake and their decision making, but then they co-opt that into grid management in conjunction with PG&E for a better optimized grid.
Interesting. And I believe one of their goals is low carbon. They want to achieve low carbon supply, and they can actually program the microgrid, the controller, correct, to orchestrate their generation so that is achievable. Is that correct?
Exactly.
Yeah.
So the intelligence of not only where to get power, but when to produce, when to store, when to consume. And they have a captive membership, if you will, in the community, so they can also influence power consumption habits. So all those things let them optimize their solar generating assets, their storage generating assets in conjunction with the utilities generation assets as well.
Interesting. And so Siemens is involved in a really fascinating project, a little more futuristic, in Brooklyn, and it's using blockchain. Can you tell us what blockchain is and a little bit about this project?
Well, blockchain is an interesting technology that I think the majority of people who understand it, they start from a financial transaction perspective. And it certainly is that. But if you look at blockchain as being a cloud-based transaction management system, It allows us to start monitoring, tracking, and facilitating energy transactions, whether it be financial, operational. And if you think about just one concept of what they're doing in Brooklyn, they have 2 communities, 250,000 member communities that want to start exploring options of energy management for themselves, independence, sustainability, and economic. If you think about energy swapping or energy sharing at the kilowatt level, you could turn just the tracking of the economics of kilowatts that in that part of the country, is maybe a 15 to 20 cent a unit transaction. The administrative costs of tracking where the kilowatt hours are moving between 250,000 participants alone would exceed the value. So in the case of our partner LO3 and Siemens, we're exploring the ways to interject and leverage blockchain in a transaction management layer in addition to an information and decision support capability.
Fascinating. So we'll look to Brooklyn for the future.
Absolutely.
Great. Well, thank you so much, Mike. Great interview. Appreciate it.